everyone, this is our first video of Computer Science series. I'm Zainab and you're watching Studimation. Today, the topic of our video is computer architecture. The Central Processing Unit, CPU, also known as a microprocessor or processor, is central to all modern computer systems, including tablets and smartphones. The CPU is very often installed as an integrated circuit on a single microchip. The CPU has the responsibility for the execution or processing of all the instructions and data in a computer application. The CPU consists of control unit, CU, arithmetic and logic unit, ALU, registers, and buses. Early computers were fed data while the machines were actually running. It wasn't possible to store programs or data, which meant they couldn't operate without considerable human intervention. In the mid-1940s, John von Neumann developed the concept of the stored program computer, which has been the basis of computer architecture ever since. The von Neumann architecture had the following main novel features, none of which were available in computers prior to the mid-1940s. The concept of a central processing unit, CPU or processor. The CPU was able to access the memory directly. Computer memories could store programs as well as data. Stored programs were made up of instructions which could be executed in sequential order. There are many diagrams of von Neumann CPU architecture on the internet. The following diagram is one example of representation of von Neumann architecture. Components of the Central Processing Unit. The main components of the CPU are the control unit, arithmetic and logic unit, and system clock. The arithmetic and logic unit, ALU, allows the required arithmetic, example plus, and shifting or logic, example and or OR operations to be carried out while a program is being run. It is possible for a computer to have more than one ALU to carry out specific functions. Multiplication and division are carried out by a sequence of addition, subtraction, and left or right logical shift operations. The control unit, CU, reads an instruction from memory. The address of the location where the instruction can be found is stored in the program counter, or PC. This instruction is then interpreted using the fetch, decode, execute cycle. During this process, signals are generated along the control bus to tell the other components in the computer what to do. The control unit ensures synchronization of data flow and program instructions throughout the computer. A system clock is used to produce timing signals on the control bus to ensure the vital synchronization takes place. Without the clock, the computer would simply crash. The RAM holds all the data and programs need to be accessed by the CPU. The RAM is often referred to as Immediate Access Store, or IAS. The CPU takes data and programs held in backing store, example a hard disk drive, and puts them into RAM temporarily. This is done because read-write operations carried out using the RAM are considerably faster than read-write operations to backing store. Consequently, any key data needed by an application will be stored temporarily in RAM to considerably speed up operations. Registers. One of the most fundamental components of the von Neumann system are the registers. Registers can be general or special purpose. We will only consider the special purpose registers. Current instruction register stores the current instruction being decoded and executed. Accumulator. Accumulator is used when carrying out ALU calculations. It stores data temporarily during the calculations. Memory address register stores the address of the memory location currently being read from or written to. Memory data buffer register stores data which has just been read from memory or data which is about to be written to memory. Program counter stores the address where the next instructions to be read can be found. System buses, or simply buses, are used in computers as parallel transmission components. Each wire in the bus transmits one bit of data. There are three common buses used in the von Neumann architecture, known as address bus, data bus, and control bus. Address bus. As the name suggests, the address bus carries addresses throughout the computer system. Between the CPU and memory, the address bus is unidirectional. That is, bits can travel in one direction only. This prevents addresses being carried back to the CPU, which would be an undesirable feature. The width of a bus is very important. The wider the bus, the more memory locations that can be directly addressed at any given time. Data bus. The data bus is bidirectional, allowing data to be sent in both directions along the bus. This means data can be carried from CPU to memory and vice versa, and to and from input-output devices. It is important to point out that data can be an address, an instruction, or a numerical value. As with the address bus, the width of the data bus is important. The wider the bus, the larger the word length that can be transported. A word is bits which can be regarded as a single unit. Example, 16-bit, 32-bit, or 64-bit word lengths are the most common. Larger word lengths can improve the computer's overall performance. Control bus. The control bus is also bidirectional. It carries signals from the control to all other computer components. It is usually 8-bit wide. There is no real need for it to be any wider since it only carries control signals. Thank you for watching Studimation, animated educational videos.